This is a two-computer Novell NetWare setup currently archiving files from a client computer to the server. As each file reads off the client system, as seen in the bottom right, you can see the file appear in the station display in the top left. Both of these machines are emulated IBM PC 5150s, which might not seem notable until you learn that you're seeing the only version of Novell NetWare for the original IBM PC that is known to have survived to the current day. At least for me, I personally think seeing an IBM PC 5150, even only in emulated form doing networking, is a very cool thing. Prior to this, while 8088 compatible NetWare clients and utilities were available as part of NetWare 286 releases, the server generator, known as OS Gen, wasn't. I've covered NetWare in the past, but for those who aren't familiar, NetWare is one of the largest names in networking. Originally founded in 1983, Novell and NetWare would go on to dominate corporate networks throughout the 80s and 90s before being eventually pushed out of the market by Microsoft. These disk images were sent to me as cryoflux dumps by an anonymous submitter, but they didn't work out of the box. For one, early versions of Novell NetWare required a license protection keycard, which was physically installed in an empty expansion slot. These came my way back in March, but at the time I didn't have enough spare time to generate a key bypass or even work on this, so I sent the images to Michal Nikasik of the OS2 Museum. I've worked with him previously on rebuilding a damaged copy of Xenix 2.2 back in 2017, and we both have an interest in NetWare preservation among many other things. I would go check out his site, the OS2 Museum, if you really want to get to the real nuts and bolts of early computing. Michal first determined that the disks had been dumped incorrectly. NetWare 2.0a had been shipped on multiple 5 1/4 double density disks, but the cryoflux images had been generated in a high density disk drive, with the drive trying to read 80 high density tracks instead of 40 double density ones. The end result was that every other track was readable, and the source of these images indicated they were not going to be able to redump them. Fortunately, the HXC floppy emulator, a project to create floppy disk emulators, also includes tools for working with and manipulating raw disk dumps. With a bit of effort, it is possible to generate usable disk images by deleting every other track and then exporting an image file, which would recreate the original 40-track image. That's the first hurdle passed. Almost. Unfortunately, it was at this time we discovered that the media set was missing a disk. In addition to the 18 disks we did have, the install disk was missing. The install disk had the utilities to set up and configure hard drives to use with NetWare, but as we'll see, I was able to use some creativity to work around this problem. Michal was also able to work out the necessary edits to bypass the license check and posted an article over on OS2 Museum about it, which I'll link in the description for those who want to read the technical details. That left the problem of actually getting it running to me. Early NetWare was typically started with a boot floppy from a minimum MS-DOS environment and a copy of NetOS created by the OS Gen disks. Before we could do that though, we had to tackle the hard drive problem. Under normal circumstances, the install utility would create the sys volume and copy the contents of the public disks to the hard drive, which then would be used by client systems for things like login.exe. However, this is when I had a brilliant idea. While this was the only known disk set of NetWare 2.0 for the original IBM PC, there were other early dumps of NetWare, specifically Advanced NetWare 2.0 for the 286. Now, it should be clear you can't run the 286 version of NetWare on an 8088. It will simply crash out or refuse to run. Besides the introduction of protected mode, 286-based IBM PCs had a revised hard drive interface known as the AT attachment or ATA interface. The two are, from a hardware and programming perspective, entirely different from each other. However, I suspected that the on-disk format and file system were the same between the two versions. Furthermore, hard drives and emulators are simply flat files. I could simply load the disk in a 286 and 86 box, format it, and then attach it to an 8088, and hopefully it would all work. This isn't quite as simple as I make it out to be, since there are issues relating to disk geometry and such, but with nothing to lose, I set up an emulated 286 with an internal 10MB hard drive attached to an IDE controller, configured the BIOS, and then loaded up the start program from Advanced NetWare 286. This throws us into a very bare bones installer that first runs CompSurf. After grinding away for a while, the NetWare installer then creates the sys volume and copies all the contents of the public disks to the hard drive. Afterwards, we're prompted to restart. At this point, I switched 86box to emulate an IBM PC 5150, reattached the hard drive, and booted from an IBM DOS floppy disk. Next, I had to run OS Gen, and oh man, this was frustrating. Unlike modern operating systems, but similar to vintage Unix systems, NetWare has to be reconfigured and relinked with a generator tool. This generates a copy of NetOS specific to your hardware configuration. In and of itself, it wouldn't be too bad if the tool required to this wasn't one of the jankiest things I've ever used. First problem, OSGen requires you to hit the insert key on the numeric keypad to actually do anything. Just to add insult to injury, OSGen doesn't respond to just the regular insert key as you might find on a regular keyboard, as that key did not exist on the original 83-key PC keyboard. Complicating matters, I also couldn't figure out a way to send this key press from a MacBook Pro, which lacks a numeric keypad, nor could I get the on-screen keyboard in Ubuntu to do so. I eventually found an external keyboard which had a numeric keypad, which let me get past the screen. This led to the second problem, which is the OSGen application will self-destruct after you use it once. I don't know if I'm on too new version of DAWs or if I'm invoking OSGen wrong, but after any attempted run, subsequent runs would always error out with this error message, and I would have to use a fresh copy of the disk to try again. It's very clear to me why NetWare used to require very expensive paid techs to care and feed for it. Anyway, after muddling through this, I wait 8 minutes for the NetWare kernel to link, and boom, NetOS, which runs and then dies immediately after with a key error. Fortunately, Mihal provided a Python script to patch out the key check. After running it, we can see a NetWare 86 start up. This is what we call winning. After this, I need to build the NetWare client, or shell as it was called in these versions. This is done with shgen and is essentially the same process as OSGen. Now, given I've already set up the tap network between the two 86box instances, we can connect, log in, and there you have it. 1984 networking with all the trimmings. Now, if I could only go less than 4 months between filming this footage and actually getting a video out. Oh well. If you've enjoyed this content, consider supporting the channel with a membership or unlocking exclusive content with Patreon. I hope once I finish moving, I will be able to return to making more long-form content. Until then, this is your host N Commander signing out and wishing you all a pleasant day.